Good morning, students. Today let us learn about the very important energy, that is potential energy. The word potential suggests possibility or capacity for action. Potential means capacity for certain action or possibility of certain action. So, the energy possessed by a body by the virtue of its position or by the virtue of its configuration is called as potential energy. As you all know, potential energy is the energy possessed by a body by the virtue of its position or by the virtue of its configuration. And potential energy also means stored energy. The meaning potential energy is also having the meaning of stored energy by the virtue of configuration or position. Examples, as I have quoted earlier: stretched spring or compressed spring. Stretched spring or compressed spring. The spring configuration is changed here. So, by the virtue of change of configuration of spring, you will be able to get certain energy released. The moment you release this compressed spring, it jumps. Yes, it is capable of doing work. So, it is called as potential energy. In the same way, stretched string of a bow. Stretched string of a bow. When you take arrow and stretch the string by keeping the arrow, and when you stretch the string and release it, the arrow goes out with a very high speed. So there is a release of this stored energy in the form of kinetic energy. When stored energy is released, it is converted into another form, that is what we call it as kinetic energy. So such a form of energy is called as potential energy. Let us consider a case of gravitational potential energy. What is that gravitational potential energy? Suppose a body, a ball of mass m, this is a ball of mass m, which is raised to certain height h against the gravity. The gravitational force acts on the surface of the earth everywhere. So, when this is a ball of mass m, when you raise it to a certain height h, at every point there is a force acting vertically downwards. Gravitational force acting vertically downwards. So, what is the gravitational force acting vertically downwards here? Gravitational force here is minus mg. Why it is minus mg? Because the gravitational force acts vertically downwards, minus mg. So, if at all you want to take it to certain height, one has to do work. So, work has to be done against this gravitational force. The gravitational force is always acting vertically downwards. Suppose this is a body of mass m, duster is of mass m. I am lifting it from the ground to certain height h. So, I have to do work, right? So, this work has to be done against the force of pull. So, such a work which is done against the gravitational force is stored in it by the virtue of its position, in the form of gravitational potential energy. When I release it, it falls down. So, that potential energy is converted into kinetic energy. So, such an energy is called as potential energy. So, in this example of gravitational force, the work done against gravitational force minus mg in raising the body through height h is stored in it in the form of particularly gravitational potential energy. Gravitational potential energy. So this work that we do in lifting it, so this is an external agency. What we do, the work is external agency. So work done by the external agency against the force of gravity is taken positive. Therefore, if you calculate work done by the external agency, then it becomes mg into h, where mg is the gravitational force and h is the height through which it is raised. So this itself is stored in the form of gravitational potential energy. In short, we call as gravitational potential energy. In these two cases, it is change of shape, change of configuration, change of shape or change of configuration. So here it is work is done against a spring force. The work is done against spring force. In the case of compressed spring and a stretched spring, the work is done against the spring force. That is stored in the form of spring potential energy. Spring potential energy. And in this case of stretched bow, you can say elastic potential energy. Elastic potential energy. So in this way, we should be able to identify the different types of potential energies. Gravitational potential energy is one particular form. Work done against the gravity in raising the body through certain height h is stored in it in the form of gravitational potential energy. Work done in stretching the string is stored in that stretched string in the form of elastic potential energy. Work done in compressed spring or work done in stretching the spring, stretched spring, is stored in that stretched spring in the form of spring potential energy. The moment you release it, it is converted into kinetic energy. I think you got the point as far as potential energy is concerned. Now, here elastic force is there, spring force is there, and here in this case gravitational force is there. So you need to identify the forces. What are the forces here? Spring force. Work is done against spring force, and here work is done against elasticity. It is called as elasticity, elastic force. That's what we are going to learn later, one by one in detail. Here work is done against gravitational force. So gravitational force, like that. The potential energy is the stored energy only for one particular class of forces, such that when the work is done against that class of force, then only the energy is stored in the form of potential energy. That class of force is called as conservative force. It is called as conservative force. So conservative force is that force, the work done against it is stored in the form of potential energy. Then what are these conservative forces? Examples are here. Gravitational force is one conservative force. So spring force is another conservative force. So elastic force, tension in the string. Tension, by stretching it, the tension in the string increases. So tension in the string, elasticity is another force, right? So when we release it, it is converted into another form. Such a class of forces is called as conservative forces. So conservative forces are those forces work done against it is stored in the form of potential energy. Then there is another class of forces. It is called as non-conservative force. Then what is non-conservative force? Quite naturally we can define it very simple way. Non-conservative force is that force, work done against that non-conservative force is not stored in the form of potential energy at all. For example, friction. When you are moving the duster, from one end to another end, the duster does not go back again in the same position. Again you have to move it back from the other end to the first end. For example, this is the surface on which I am moving the duster. If I move it from this end to this end, I have to do work. The duster cannot come back again on its own. If at all I want to bring it back, I have to do work against the friction. So work done against friction is not stored in the form of potential energy. So such a class of forces are called as non-conservative force. Work done against such non-conservative force is not stored in the form of potential energy. Examples are frictional force, another one viscous force, frictional force, viscous force, air resistance. So these are all class of non-conservative forces. Now we can group them, conservative force and non-conservative force. What is conservative force in general? A class of forces, work done against them. The class of forces, work done, you can say conservative forces. Class of forces, work done against such forces is stored in the form of potential energy. Example, gravitational force. So similarly, next year you are learning electrostatic force. Electrostatic force existing between like charges and unlike charges, or electric force you can call electrostatic forces. These forces are, like charges repel each other, unlike charges attract each other. So both repulsive force as well as attractive forces club together as electrostatic forces. Magnetic force. Magnetic force between like poles and unlike poles. Like poles repel each other, unlike poles attract each other. So these are also class of forces called as conservative forces. And buoyant force. Buoyant force. Buoyant force is also conservative force. If you take a wooden block into the water, wooden block always floats on the surface because of high buoyant force exerted on the wooden block. If you press that wooden block down inside the water and release, again the wooden block is pushed upwards. So work done against the buoyant force is again conserved in the form of potential energy. The moment you release it, that potential energy is converted into kinetic energy. Work is done by the buoyant force. So such a class of forces are called as, conservative forces. Like that you can list different forces. Next, what are non-conservative forces? Non-conservative. Non-conservative forces the forces against which the work done, the class of forces, you can say, work done against such forces is not stored in the form of potential energy. Example, all dissipative forces, they are all called as dissipative forces, means the work done against such friction force or air resistance or viscous force is stored in it in the form of, it is converted into heat. So you can frictional force, viscous force and air resistance. This is a class of forces. So work done against such class of forces is not stored in the form of potential energy. As I gave you example, if I move this duster from one end to another end, if I want to bring it back, again I have to do work. Whereas in case of gravity, you can just see, when I lift it, I am doing work against the gravity. But when I release it, the gravitational force does the work. So such a class of forces is called as conservative force, and this is the force wherein the work done is not conserved in the form of potential energy. Such a class of forces is called as non-conservative force. Okay. Okay, let us see the example of gravitational potential energy. Just now I have said, if an object of mass m is raised to certain height h, then the work done by the external agency is W is equal to mg into h. In this situation, we have assumed that the acceleration due to gravity is constant. The acceleration due to gravity, we take it 9.8 meter per second square as constant near the surface of Earth. Near the surface of Earth means what? Near the surface of Earth means for ordinary heights. For height, this h, for h which is very much less compared to radius of Earth. For such heights which are very much less compared to radius of Earth, we take ordinary heights, and for such ordinary heights we assume that acceleration due to gravity g remains constant. But you will study later on in the topic of gravitation how acceleration due to gravity varies as we go to the greater and greater heights. Variation of acceleration due to gravity we are going to learn as a function of height, as a function of position later in the topic gravitation. But for ordinary heights we take g to be constant, so that the gravitational force here is minus mg. So this itself we take it as potential energy. What is this? UH. U is the symbol for potential energy. U is the function of h, and in particular this is gravitational potential energy. So gravitational potential energy I will write as UH is equal to mg into h. Now I can obtain which is the conservative force involved in this by a procedure called as differentiation. If I differentiate it with respect to the variable, what is the variable here? Only variable here is height. As I told you, mass of the body is constant, and I have told you g is assumed to be always constant. Only variable here is h. As h increases, potential energy increases. As h decreases, potential energy decreases. So only variable here is h. So if we differentiate it with respect to h, negative differentiation, if we take negative differentiation of that, then we get which is the conservative force involved in this. So differentiating with respect to h, we get differentiating with respect to h, we get du by dh. Du by dh is equal to mg into dh by dh. You see, mg being constant, I have taken it out. So dh by dh becomes 1. Differentiation of h with respect to h becomes 1. Therefore, it becomes mg. But mg is the force that we have applied. But gravitational force is minus mg. Therefore, take negative differentiation. Multiplying with negative. Multiplying with minus sign, we get minus du by dh gives us minus mg. This minus mg is gravitational force. That is what we got as Fg, gravitational force. So that's how we get the conservative force that is involved in any form of potential energy. Later on you are going to learn about spring potential energy. So if you do the negative derivative of spring potential energy with respect to position, with respect to stretch, you will get spring force, right? So negative derivative of elastic potential energy, if you carry out, you will get elastic force, that is tension. So these things you are going to learn later. So in general we can state here what is a conservative force. Conservative force is that force which is equal to negative derivative of gravitational potential energy. So conservative force is equal to negative derivative of potential energy. Negative derivative of potential energy. It means if it is F is equal to minus of du by dx, where in general we take x as a position variable, right? So u is potential energy, x is position variable. So this is the second way of defining what is potential energy. So potential energy is that stored energy, work done against conservative force is stored in it in the form of potential energy. I think you got the point. Potential energy is the stored energy when work is done against conservative force, or vice versa. In the reverse order, what is conservative force? Conservative force is the force work done against the conservative force is stored in the form of potential energy. So potential energy is possible if and only if work is done against conservative force. Work done against conservative force is stored in it in the form of potential energy. We will stop it now. Tomorrow we will discuss about the how work done is depending only on initial and final position. It depends only on initial and final position. Gravitational potential energy or any form of potential energy depends only on initial and final position. It does not depend on path. It is path independent. The work done is path independent. It depends only on initial and final position. And work done in the closed path. For example, when you take it from this height to this height and when you release it, the work is done by the gravity. When I am raising it, work is done by me. That is plus W. If I am raising it from the table surface to certain height, I am doing the work. So it becomes plus W. When I leave it, it becomes minus W. So work done in this closed path. Can you get the point? Work done in this closed path is 0. So conservative force is that force. The work done in the closed path is 0. So these are the three ways we define what is conservative force. This is first way. The force work done against which is stored in the form of potential energy. This is the second way. The force which is expressed as negative derivative of potential energy. The third one, the force, the work done against which depends only on initial and final position. And the fourth one, you can say work done in the closed path is 0. So such class of forces are called as conservative force. Thank you. Have a nice day. We will continue it tomorrow. Good day. Bye.